Uh, Good morning, everyone. Patrick.
Jean, yes, people are entering the room.
I was trying to check if the sound on my side, you hear me very well.
Yes, it is okay, we hear you. Just give a few minutes to join.
Yes. Yeah. Okay. So, dear participants, dear presenters, dear moderator, good morning.
Morning.
On behalf of the technical committee organizing the NBDF 7, I'm highly welcoming you to this webinar session on aquatic ecosystem under threat from anthropogenic activity. The key highlight here is that the Nile Basin has many unique aquatic ecosystems and is home to thousands of species of plants and animals. Many of them are endemic to the basin. Understanding the impact of a anthropogenic factor on the aquatic ecosystem require our deep understanding of the environmental flow of this system, consistent monitoring and assessment of ecosystem health, and putting mitigation measures to further degradation on an unsuitable use of aquatic ecosystem. We invest in different aquatic ecosystem health. Member states have also been deliberate in putting in place policies and the regulatory framework that protect the aquatic ecosystem from the effect of human activity. For example, most of NBI member states are signatory to the key international treaties and the Convention for the Protection of Key Aquatic Ecosystems, such as the Convention on Biological Diversity, the Ramsar Convention on Wetland, the Convention on International Trade in Endangered Species of Wild Fauna and the Flora, among the others. So this webinar session has 7 presentations, and the moderator of this session is Mary, who will be supported by Richard Kiambade, who is trying to join as well because of internet connection. Let's first introduce to you Mary Namukos. Mary Namukos is who will be the moderator of this session, is an advisor for water resources, climate, and environment at the GIZ Uganda Transboundary Water Cooperation, the Nile Basin Program. Her current work involves supporting projects addressing sustainable use and management of wetland and peatland resources in the Nile Basin and the plastic pollution. Ms. Namukos holds a Master's of Science degree in tropical aquatic ecology from the University of Bremen, Germany. She has been working in international development cooperation for almost a decade, focusing on topics such as integrated water resource management, water source protection, planning and implementation, water stewardship through building public-private partnership, and circular economy. The floor is yours, Miss Mary Namukos. Thank you.
Thank you very much, Jean. Dear participants, presenters, you're welcome to this webinar, which is also wrapping up the thematic area of ecosystem health. Our webinar, we are going to talk about aquatic ecosystems under threat from anthropogenic activities. We have very interesting presentations ahead of us, and I would like to encourage you, it's not too late, just share the link in your network to friends, colleagues, such that they can join us. To start the session, as we also wait for my co-moderator to join, Mr. Richard Kiambade, I would like to introduce to you our first presenter, Mr. Zelek Kebebwa Chala. Apologies if have not pronounced your name well. Zelek holds a master's degree in GIS and remote sensing with an experience of over 16 years in the field of Earth observation and geospatial applications. He has experience with different organizations, has worked with quite a number of international organizations such as Farm Africa, IGAD, UN, OCHA, and he's currently working for the Nile Basin Initiative as the Earth observation and remote sensing expert. His major areas of experience or expertise include cartography and data visualization, geodatabase designs and implementation, digital satellite image analysis, spatial analysis, among others. His research interest is in the application of GIS and remote sensing in the environment, water resources, land use, and climate change. Welcome, Zelek, and Zelek is going to take us through an interesting presentation about the Atlas of Transboundary Wetlands in the Nile Basin. Thank you very much, Zelek. The floor is yours.
Thank you very much, Ms. Mary. My name is Zeleka. I work for Nile Basin Initiative as Earth observation and remote sensing expert. The topic of my presentation is Atlas of Transboundary Wetlands in the Nile Basin. I don't know why it's changing. Okay. Let me start with a few backgrounds. Wetlands just provide variety of services that are essential for human well-being, including food, water supply, water purification, carbon sequestration, flood prevention, climate change mitigation and adaptation, tourism, and etc. So my slide is not changing. I'm not sure what happened. Okay. The Nile Basin is endowed with a rich mosaic of wetlands. The wetlands in Nile Basin accounts for only 1.1% of the area of the basin, but it is very important. It supports livelihood in the socio-economic development in the basin. However, the wetlands in the basin are under threat from factors like habitat loss, pollution, and climate change. Therefore, knowledge on the wetland is very important to formulate policy and also to take measures related to wetland. Acknowledging the importance of wetland, Nile Basin Initiative developed wetland management strategy in 2022 with 5 major objectives. One of the objectives of this strategy is enhance data, information, and the knowledge on wetland ecosystems and management best practices for cross-border wetlands or wetlands of transboundary importance in the Nile Basin. This atlas was developed based on this objective of the strategy. Methodology and data sources. The atlas was developed primarily based on Nile Basin Initiative wetland inventory data and a document. This inventory project mapped and described overall wetland situation in the Nile Basin using remote sensing technology and supplementing this information with data obtained through field campaigns, literature review, and the stakeholder consultations. So the inventory came up with 68 wetlands of transboundary importance in the basin, which is utilized in this atlas. other data sources we utilized for this atlas is like the FAO database, OpenStreetMap, and other sources. So the content of the atlas has around 11 chapters and 180 pages. Chapter 1 focuses on description of the methodology. The rest of the chapters, 10 chapters, focus on individual wetlands, and these chapters are divided into 10 based on subbasins. We have like 10 subbasins in the Nile Basin. And the wetland specifically focuses on more than 50 wetlands. And the atlas, like 50 wetlands are cross-border wetlands, landscapes shared by at least 2 countries. And 20 are Ramsar sites. They have international importance, and the rest are important bird areas. And only these wetlands are considered in this atlas. Not all wetlands are covered in this atlas. So the atlas, as I've mentioned, chapter 1 focuses on the methodology and the background. The rest of the chapters are presented based on the subbasins. The subbasin, each chapter, they start by introducing the socioeconomic and the hydrological context of the subbasin in relation to wetland. For example, here we can see the Lake Albert subbasin, the socioeconomic context and the hydrological context. The next to presenting this, the chapters focus on individual wetlands. For example, if we can take Lake George wetland, it is an individual wetland. At the top, you can see the red box. It presents the most important information, like its location, area, importance of that wetland, and then next to this most important information, there is map. This map consists of like the wetland boundaries, protected areas, peatland, which is also developed by the Nile Basin settlement, and etc. Then next to the map, there are photographs, description about that wetland, what's happening to that wetland, the ecosystem service of that wetland is presented in the atlas. And this atlas is very important in many aspects. One, because it provides synthesized information briefly for stakeholders. It can be first-hand information to work on wetland. And then this wetland, it's present is a special distribution of the main wetlands in the hydrological basin context. This atlas can serve as a foundation for scientific research and the monitoring programs. It can be also a reference for policymakers and other researchers. So during the development of this atlas, there were challenges, especially when we were developing the database. One of the challenges were delineating wetlands that have variation in spatial extent over the wet and the dry season. This is because of the data we have, such as remote sensing data. Remote sensing data has its own limitation in terms of temporal resolution, seasonality, spatial resolution. The other problem was just from data gap in the field. Nile Basin is a big basin. It's difficult to reach every places to make a ground truthing. So this was a challenge. Cloud cover was also another challenge during the interpretation of the remote sensing data to drive the wetland extent. So those cloud covered area were excluded and later compensated by secondary data like from FAO database. The other challenge was just related to the wetland management. The wetland in the Nile Basin is suffering from encroachment and conversion of in agricultural lands, residential area, industrial area, sea, and wetland pollution was also another problem. Biodiversity destruction is there. There is also a problem related to institutional capacity building, public awareness, also another problem. We recommend this recommendation. The first recommendation is educating the public about the importance of the wetlands, because the encouragement is most of the time it is done by the public. So educating the public is very important. Second is data sharing and the collaboration among government agencies, research institutions, NGOs, and other stakeholders is very important to manage the wetland in the Nile Basin. Updating the wetland data regularly to reflect changing conditions, because the wetlands are always changing. The changes related to conversion to agriculture and climate change. Establish and support long-term monitoring program for the wetlands. Monitoring is also very important. And working on laws and the policies, especially on the law enforcement, is another recommendation. Thank you. Over to you, Ms. Mary.
Thank you very much, Zelek, for that wonderful presentation. Fellow participants, I would like to encourage you to put your questions that you might have for Zelek in the chat, and we have an option to answer questions as the webinar progresses, but also at an opportune time we shall give some people who have burning questions an opportunity to ask questions live. Please allow me to go to our next presenter, Dr. Gideon O'Brien. Dr. Gideon, if you could switch on your camera for the participants to see you. Dr. Gordon is a professional scientist and South African National Research Foundation rated researcher from the Rivers of Life program, University of Mpumalanga, South Africa. His career vision is to undertake evidence-based research on water resources and their response to multiple stressors for a sustainable future. He has 18 years of experience in water resources management and protection, ecological risk assessments, aquatic ecology, ichthyology, and fisheries, environmental flow assessments, and ecotoxicology. Dr. Gordon has worked in 16 African countries and collaborates with more than 10 international universities and institutes. Dr. Gordon has published more than 60 peer-reviewed publications and book chapters in international journals. His topic will be environmental flow management contributions to sustainable water resources in the Nile Basin. You're welcome, Dr. Gordon, and the floor is yours.
Thank you very much, Mary. Just to confirm, can you hear me clearly?
Yes, we can, and we can also see your presentation.
Thank you very much. So thank you, everybody, for the opportunity. I'm going to give you a bit of a review and really try to unpack the value, the potential for environmental flow management to contribute to water resource management. And the case study that we're going to look at today is the Nile Basin. So I'm going to look at what is environmental flows, talk about the Nile and what's been done in the Nile, compare methods versus the framework, and try to support the prospect of using the framework, and then look at the Nile e-flow strategy. What my presentation is based on a range of documentations, and we're busy working on another publication to demonstrate how environmental flows can contribute to sustainable water resources use in the Nile Basin. But we've done quite a lot of work with the Nile Basin Initiative over the years, and I'm primarily using information that we generated through one of our initial guidance document development studies that we carried out in the Nile Basin. And then I'm also going to look at the some of the outcomes, discuss some of the outcomes from the biodiversity conservation, sustainable utilization of ecosystem services. And I'm just going to refer to the SUD wetland environmental flow assessment that we've done. So to start off with, what is environmental flows? So environmental flows are the quantity, timing, and quality of freshwater flows and levels are important for wetlands, that are necessary to sustain aquatic ecosystems. And we know that if you provide the requirements to maintain ecosystems, you will then in turn support human cultures, economies, livelihoods, and well-being. So environmental flows are is a field of study. It's a study area or topic where we try to determine the volume, timing, duration, frequency of river flows and or levels in lakes and wetlands that are required to sustain those systems. The first thing that you need to consider is that in order to be sustainable, an ecosystem doesn't necessarily need to be pristine. So what we determine, first of all, is that we want to make sure that the biodiversity of a particular catchment area, key ecosystem processes of a catchment area are protected and in place. So you can see then that if in some areas, if you are protecting ecosystems and maintaining biodiversity hotspots, in other areas you have the opportunity to use water resources, but that use must not be excessive. And that's what environmental flows are there to determine, is how much water can be used and when can the water be used in any given area within the basin in different water resources at different times of the year, in order to make sure that those ecosystems are sustainable and not overutilized and or become unsustainable, and that the whole catchment, the catchment as a whole, maintains the biodiversity and the important processes that we care about and we need. So in effect, if you've picked that up already, environmental flows is a very useful approach to contribute to the sustainable balance between water resource use and water resource protection. And this is something that has been adopted globally. And fortunately, in the Nile Basin, it has been established and is being incorporated into management plans throughout the basin. So on the right-hand side here, I have I'm just going to put a laser pointer on. I just have a very schematic indication of how it works. So what happens is, if you have the study areas, such as the Nile Basin, you would then determine how much water is required in a particular area to maintain that ecosystem, how much water is available for use. And then you need to then be able to look at how much is being used, how much water is available to be shared across the basin to, first of all, maintain the ecosystems that we care about across the basin. After the environmental flows, then we can determine how much water is allocatable, how much of the flows are allocatable for use, but that is a completely different process to then decide how flows are being allocated for use. What we're interested in is determining from the ecosystem how much water is available so that we can maintain our ecosystems. I put the slide in here because I just wanted to show you is that environmental flows are dynamic. We all know that the upper part of the Nile Basin catchment area is a water source area where the majority of the rainfall falls in this upper part of the catchment and flows downstream. And everybody else downstream of the upper part of the catchment is dependent on that rainfall and river flows that flow downstream, including some of the important wetland areas. But if you look at the history of the hydrology in the study area, you can see that you've actually been through different phases of dry periods and wet periods. And this is a very interesting graph that I always love going back to, because it shows you that between 1920 and 1960, the base flows of the outflows of the Nile River, and this is from different locations across the basin, but you can see that the flows available in the catchment were significantly lower than what we've observed post-1960. So you need a good idea of what the systems have experienced already and how much water is required in the context of what the system has experienced. And then very importantly, if you're in a period, a wet phase, which is what we've been in since the 1960s, you need to remember that we could very easily return to a drier phase. And if you return back to a drier phase, what would the volume, timing, duration, and frequency of flows look like or be in that period? So environmental flows are dynamic. We need to look at environmental flows on a holistic scale. We need to consider the whole basin because we're all part of the same catchment area. River flows downstream, but species and biota moves upstream. So we're all connected and we all need to work with one another. But one thing that we can determine is what has been in the ecosystems historically before people have developed our environments, what is required to maintain our ecosystems and their biodiversity and ecosystem processes. And once we've determined what those requirements are, we can then start to allocate flows after that. And that's something that we think that we're all buying into and we're using. So the initial assessment when we developed the environmental flow manual and which led to the development of the environmental flow strategy for the Nile, we actually looked at these 4 case studies, the Kagera River, the Mara River, the Dinda River, and then one of the ecosystems in Uganda. And what we established, first of all, is just to demonstrate how the environmental flow process works. What are environmental flow assessment methods, and could we apply those methods in different types of ecosystems? And all of these case studies, by the way, were transboundary catchment areas or transboundary subbasins of the Nile. And we were able then to demonstrate how once we determined what the ecosystems required, those areas were then provided with that control information. We refer to it as control information because you get a sense of how much water is required to keep the system functioning and to keep the processes going, to which the people depend on. So there is a human element in these 4 areas. And that was the initial assessment we done to demonstrate that it can be done. Once we had demonstrated that it could be done, we then reviewed and provided an understanding of different environmental flow assessment methods that are available, different guidelines and frameworks that are available across not only the basin, but also across the continent and the world. And then to show us that, this is an adaptive process where we need to start somewhere and start to establish environmental flow requirements in different parts of the basin, and then move towards environmental flows and the environmental flow requirements and the sustainable management of water resources in different parts of the basin. The next assessment we did, we were able then to apply existing information and new tools. Also keep in mind that the world and technology is developing, and we have a range of new assessment methodologies to model and understand our hydrology. We often in environmental flow assessments need to look at hydraulics, so we need to understand not only what the flows have looked like and how has it varied, but what do the flows look like in a particular ecosystem. So we need that habitat element, and we need to understand when there's a little bit of water or there's a flood, what do the habitat characteristics look like in that particular ecosystem? We've also got very interesting and new methodologies to help us monitor and evaluate the invertebrate and fish and riparian vegetation communities. We've got new fancy tools that can, for example, environmental DNA that can help us determine whether species still occur in particular areas. And once we know what's there and we've got some understanding of the biology, we know what they need. So ultimately in environmental flows, you're looking at different components of the ecosystem's needs. And once you've packaged those needs together, you get an understanding of how much water then is required to sustain that ecosystem and the important functions of that ecosystem. And this is the type of outcomes that we provide to stakeholders for an environmental flow assessment method. So this is an example where you can see this is the amount of water that was available at one of the sites in the Kagera River. This is the portion of the requirements that are required to maintain that ecosystem, 10% of the floods, 47.7% of the low flows. We did not specify drought flows in this study. It could have been based on available data, but the total to maintain that ecosystem and its associated ecosystems, such as the floodplain wetlands, would require 57% of that, the natural flows. But that's also not necessarily what people will implement, because you can still have the opportunity to decide whether you're going to push this river to become a working river, which means you want to still be sustainable, but you're going to use more water. Importantly, if you can offset the ecosystem requirements in other areas. So that's how, for example, we provide a B, a C, and a D ecological category environmental flow. So you can see here, you can just get an idea of, for the B, C, and the D, that you go from 58% of the flow requirements down to 38 and 21. And we provided all of this information so that people can understand what are the consequences of the way that people are using water resources. And then importantly, if you're going to push this particular catchment area and make it work very hard, where are you going to sustain and maintain another ecosystem? In different catchment areas, and I'm moving on to the second area, this is downstream of Lake Victoria Ginger. You can see here that the requirements are very similar. These lines are very close, although the MR is very different. And again, we've provided the environmental flow requirements to maintain the system in a B, C, or D category. And we can move through the whole basin. We've done it again downstream, upstream of the Sud wetland in the main stem now, in some of the small tributary areas. This is Risk Region 4, which is at Gambela. We've got a site downstream of the Sud River, the Sud wetland. We included some sites in the White Nile, upstream of the confluence, in the Blue Nile at Rosaries, in the Dinda River. Oh no, this is not the Dinda. This was the Atbar River, for example. This is just below that new big dam on the Atbar River, and then in the Lower Nile River. So we're trying to provide the information that you need to allow stakeholders across the basin not only to know how much water is required and what part of the ecosystems would be maintained, and what the consequences would be of using too much water in terms of an ecosystem, but also to allow people to synchronize environmental flows. And that's why you need to look at it on a basin scale to see, if people are utilizing one part of the catchment, what would the implications be, and what would the downstream implications be in terms of maintaining our ecosystems, our water resources. What we provided as a very simple output is this flow duration consequence tool. So if you then, most hydrologists across the basin are quite familiar with these flow duration tables, these exceedance tables. On the left-hand side here, you can see for a particular scenario, you can describe, this is reference scenarios B, C, and D templates. You can then determine how much flow you are is available in the system, and you can look at the variability of flows that you've provided. These tables also consider base flows and low flows. And if you put the flows into the table that you're experiencing, you'll get an indication of what part of the flows are you providing for and what areas you may have particular issues. So we're trying to guide users as much as possible towards implementing environmental flows and understanding the consequences of altered flows. In our assessments, ladies and gentlemen, we've also provided some indication of different environmental flow assessment methods and the cost benefit or the trade-offs between different methods, how much time it takes, what you get out of different methods, what you need to consider. You can see that they're all progressive. So they get more complicated or complex as you go, but then the confidence of your outcomes increases as you move forward with these different environmental flow assessment methods. And then what I also wanted to indicate here is that not only are we interested in environmental flow assessment methods, but the framework. And an environmental flow framework has been established by the Nile Basin Initiative to try and help people align all of their environmental flow assessment information into a catchment scale process where we can use information. We can also then use a lot of information from environmental flow assessments that were done in particular areas and apply that information to other areas. So if we understand what the social and ecological consequences of altered flows on a particular part of the basin, and you're interested in a similar part of the basin, we can give you that information so that you can get some indication of how your particular part of the catchment will respond when flows change. And this process also incorporates a lot of the environmental flow assessment methods, but it's more of a management framework that will allow us to bring all the information together and improve our understanding of what the whole basin needs. And ultimately, what's important if you compare the difference between an environmental flow assessment method and a framework is that methods are applied on a site scale. The information is usually applied to the reach scale. But what a framework does is a framework is there to try and contribute to the management of the whole basin. So all of the environmental flow assessment and information gets uploaded into the framework. And then that framework then is able to help us manage the Nile Basin as a whole. I hope that that makes sense. This is the framework, just to give you an idea quickly of what the framework looks like. And guys, all of this information is available on the Nile Basin Initiative website. So please, if you go look for some of the documentation, all of the information that are presented are available in technical reports. And there are some publications that are coming. So I hope that this really does contribute. But if any of these are just environmental flow assessment methods, relationships, and then application. If anybody actually needs some information, I'm sure through us or the Nile Basin Initiative, you'll be able to get some support that you would need in different parts of the catchment to support your conservation and or sustainable management of water resources. I just wanted to finish up on two little things about the strategy. So the strategy was prepared by the Nile Technical Advisory Committee and included our environmental flow assessment scientists who contributed to the development of the strategy. And this includes and is linked to the guidance documents on environmental flows that I said are available. But importantly, the vision for environmental flow management is available, where this concept of sustainability is clearly described and something that all of the members of the Nile TAC have bought into. So this is a wonderful vehicle that we can use to try and contribute to the sustainable management and or use of resources in the basin. In terms of the strategy also includes information on the framework, as well as links to the manuals and methodology assessments. There's also a series of training videos that you can look at. And then importantly, it includes guiding principles for the management of environmental flows, things like cooperation and equitable use of resources, and the adaptive management approach and evidence-based information. So that's very useful. And I must say that based on our review and work that we've done globally, this has been one of the most progressive environmental flow management programs that has occurred in the world. And I think that that's something that we can really applaud the Nile Basin Initiative for. So well done, guys. Implementation, arrangement, and responsibility includes, and here I just wanted to demonstrate that the strategy also does consider the fact that in certain areas, developers would have responsibilities to look at environmental flows. For example, if someone's building a hydropower facility, but regulators and regional managers, they are interested in the region and how their region would then contribute to the basin. So there are different roles and responsibilities for different stakeholders in the environmental flow management space and assessment space. It means that developers are not required to determine environmental flow requirements for the whole basin, but the regulators may require that developers look at environmental flow requirements for an activity and then require them to look at the implications of the altered flows on a regional scale and how that would affect then information downstream. And that information is largely available. So it is available for you guys all to use. The importance of adaptability. Guys, the idea here is that we don't have enough information about the Nile Basin, its biodiversity, ecosystem processes, flow ecosystem relationships, flow ecosystem service relationships. We have a lot, but we need more. And as that information becomes available, we need to act, we need to work, we need to do things, but we need to improve the way we're doing things as we go. And ultimately, what are we doing this for? We're doing this for our people and for the ecosystems, the Nile Basin environment that we care about. And then finally, where to, I just wanted to show you that this is hot off the press. A publication has just been published by a range of international authors looking at the acceleration of environmental flow implementation to bend the curve for global freshwater biodiversity loss. And we've been able to contribute to this publication and have included some of the case studies from the Nile in this publication. So I would really encourage you to go and have a look. Ladies and gentlemen, that's it from me. Thank you very much.
Wow. Thank you very much, Professor. I think we all have an option of clapping, even if we are attending virtually, but that was very insightful. And I think for a shared resource like the Nile, it's important to interest ourselves in the environmental flows. And from this point of view, I would like to request the colleagues from NILSEC to post in the chat the link to the environmental flow course. It's quite a good course. It has all the information and the material which you were talking about. Yeah, and thank you very much for such a wonderful presentation. Ladies and gentlemen, I would like to encourage you to put your questions in the chat, and our presenters will gladly be answering your questions. And I would also like to take this opportunity to welcome my co-moderator, Mr. Richard Chambade, who joined us in a few minutes ago. And Mr. Chambade will be taking on the co-moderation role after our next presenter. Ladies and gentlemen, please allow me to introduce to you our next presenter, who is Dr. Rebecca Walugembe Nambi. If you could switch on your camera for the participants to see you. Dr. Nambi is working with the Minister of Agriculture, Animal Industry and Fisheries in Entebbe as a senior fisheries inspector, and she has worked with the Department of Fisheries Resources for over 10 years. She has participated in several activities, including the development of the e-licensing system, the licensing strategy, and Save the Perch, Nile Perch, I suppose, among others. She holds a PhD in water management, specializing in aquatic ecosystems management from Addis Ababa University in Ethiopia. We are glad to have you on this webinar, Dr. Rebecca Walugembe. And she will be presenting to us a very interesting topic, especially for us fish lovers: identification and characterization of fish breeding habitats on Lake Choga as an approach to sustainable fisheries management. Dr. Nambi, you're welcome, and the floor is yours.
Thank you very much, dear Mary, the moderator, participants, and the hosts. Thank you so much for giving me an opportunity to be part of this webinar. As she has introduced me, yes, I'm Rebecca Nambi, and I'll be taking you through the study that was carried on Lake Choga, which is identification and characterization of fish breeding habitats on Lake Choga as an approach to fisheries sustainable management. Part of the introduction, as we may all know, the fishery is very important to us as it's a source of income and a source of nutrients to those of us who enjoy eating fish. It also contributes to food security. As we know, one of the sustainable development goals is to see that we have zero hunger, and I pray that we really keep this fish sustainably in order to have enough food. It also provides employment and development and among the people who are employed to work in the fisheries sector. And as all we do that, at the end we get better livelihoods. But as much as the fishery is very important to us, fish catches are going down, and this is not only the case of Lake Choga, but many water bodies, especially for us in the Nile Basin, looking at the lakes, the water bodies that are within the basin. We see that the capture fisheries are really dwindling, and this is associated, among other factors, human activities, especially fishing. This time we are talking about fishing as an activity carried out by human beings. And in a way, we are harvesting the broodstock, the immature fish, sometimes even the eggs, distorting the spawning cycles. And because of our activities, we are also deteriorating the buffer zones, which are also in some cases used as breeding sites. And in a way, we end up deteriorating the water quality And at the end, we see that when the water quality goes down, it's deteriorated. Our water bodies are invaded by aquatic weeds. And also we see as fishing activities, there's an increase in the use of illegal fishing gears. And all these have an impact on the catches or the abundance of fish. But also fisheries managers are not just seated and watching the situation. On some water bodies, they have employed or deployed the closing fishing seasons. On some water bodies, we see that licensing is helping to control the number of boats on the water body. On some lakes, on some water bodies, they're doing lake patrols, monitoring, control, surveillance. And we also thought of protecting the ecologically sensitive habitats, and these are the fish breeding habitats, which are suitable sites that provide biotic and abiotic conditions for fish to breed. And these mostly are found in the littoral zones. Abiotic conditions, we talk of the water quality, and biotic talk of presence of predators, presence of prey, and these are the areas that also fish prefer in order to carry on the spawning activities. And fish breeding habitats have been used on some water bodies for biodiversity conservation, natural recovery of fish stocks, and reverse habitat degradation. And we can see some examples, like in South Africa, they are called the marine protected areas. On Lake Kivu, they have also been done, and also Lake Victoria and Albert in Uganda, they have also been identified. But on Lake Choga, they were not yet well established, and that's why we had to go on with this. And we considered Lake Choga main, as we may know, Lake Choga has two arms. We have the Kwania arm, and then we have the Lake Choga main. And for our study, we concentrated on Lake Choga main, and we sampled 20 sites. And in these 20 sites, we looked at fish, we sampled fish. We also looked at the water quality. We also looked at the sediment, and also looked at the habitat vegetation, as well as we carried out the key informant interviews with some fishermen and citizens in the area. And with picking the fish samples, we used the boat seine and cast nets. And then we dissected, and we did analysis for the gonads to see if we are picking fish from this area at a known season, what could be, or what can the gonads inform us about the sites. And also the water quality samples, which we picked using those equipments, and analysis was done at the Ministry of Water Laboratory in Entebbe. We also looked at the sediment, because when we were carrying out the key informant interviews, the fishermen could associate their information with some sites, saying, we usually pick fish from this area around this season. And so they would say, usually Nile tilapia is found where there's sand. So we went on to pick samples of the sediment to really also find out what they are saying, is it true, and also to confirm with our research. And also we picked habitat vegetation from those sites, which we identified from the Botany Lab of Makerere University. And for our data analysis, we used one-way variance. We also used the principal component analysis, observations, and correlations. And the results we got looking at the fish samples, the vegetation, the sediment, and also the local knowledge that we shared with the fishermen, we could only, out of the 20 sites, we only got 8 sites that were suitable, that provided or proved to be more of habitat sites than others, looking at the samples that we collected. And we had 4 sites for Nile perch, and we also had 4 sites for Nile tilapia. And they are located, as you can see from the map. And we looked at the water samples, and these were our results compared to other studies that have been also carried out on other freshwater bodies within our within the Nile Basin. And Lake Choga, in general, the water quality is still good for fish production or for fish growth and survival. And thus, as we are looking at this topic of today, how anthropogenic activities are affecting the health of aquatic ecosystems, we should really try to see that this water quality does not deteriorate to the levels that will not support fish production or fish survival and growth. And we also did a correlation of gonads with vegetation, and we could see some sites could be really good fish breeding habitats, but because of the presence of some vegetations, the fish it could not allow fish abundance. It could not allow fish to carry on the other processes, because the presence of such weeds is like competition. It's like it makes the place unfavorable for the fish to go on. Like now, when you see the Pistia species, Salvinia molesta, it related negatively with the presence of Nile perch, because it stops the light penetration so that the oxygen formation can go on. So if there isn't enough light penetration, because these cover the surface, then there wouldn't be enough oxygen for the fish to survive, as we may all know that Nile perch is very sensitive to low oxygen levels. So through the key informant interviews, with key informant interviews with the locals, the fishermen or the people that we interviewed could identify the fish, or could relate and say, in this area, fish seem to be these seem to be habitats for fish. And we could ask why. They would say, we usually harvest fish at such a time with the eggs in the mouth, especially for Nile tilapia, or we usually find very young fish, the fry, in these areas at a certain stage. And then we went on to ask them, why do you have to lay your nets here? And they could not explain. We asked them, do you know that by doing such, you are distorting or you are interrupting, and in a way you are affecting your future life, because if you harvest the young ones, or if you distort the breeding cycles, then you will not catch fish. And they could really say, yeah, before we could get more tons of fish, but now, and they could really agree that because of what they are using, because of what they are using is in terms of the fishing gear, in terms of where they lay their nets, and they could really tell that their catches, the catches they used to have before, are lower than what they are getting. The catches they used to get before are higher than what they are getting currently. This work was done in 2022. As part of my PhD work at Addis Ababa University. And I said Nile perch showed a negative significance with vegetation types, because Nile perch is very sensitive to low oxygen levels. And if there is any vegetation that covers the surface and has an impact on the water quality, it really has an impact on Nile perch production. And in a way, okay, for this presentation, we zero down on fishing as an activity. But if you go deeper looking at the other activities that are happening around the lake, you'd see that some of these, the water quality, some of the areas that are invaded by some of these weeds, when you see around the activities going on, you see that maybe there's a landing site and the wastewater is directly discharged into the lake. So you find the quality kind of going down in that area. So if such activities increase, then we shall really have our Lake Kyoga impacted, and then the production of fish will go down, which is not good for us all as a nation and as a basin. So as we conclude, we see that reproduction, survival, and growth of larval fish are influenced by favorable environmental conditions, location, and time of spawning. And human activities that affect the aquatic environment should be worked on for sustainable fisheries management. And in a way, we are recommending that the 8 areas that were, the 8 sites that were identified and characterized should be gazetted, demarcated and gazetted, so that fishing activities do not take place around those areas or in those sites, and also sensitize on the local stakeholders on how to handle domestic waste and natural resources. Sometimes the fishermen feel like the fish cannot really get out or cannot really get finished from the lake, which is a wrong perception. And also empowering the local leaders through co-management. We can also deploy seasonal fishing at a certain time of the year. Fishermen don't go to the lake, to give enough time for the fish to grow, and then they can go and harvest. Also strengthen licensing in a way that the number of boats, the number of gears in a boat, the number of people on the lake are controlled. And also we can continue to penalize those who are using illegal gears, because mostly these people who use legal gears, they don't go to deeper waters. They're always in the littoral zones, which are also in most cases used by fish to breed because of the low water currents and other factors, and also continuous lake patrols. Thank you very much. That's the end of my presentation.
Wow, thank you very much, Dr. Nambi, for that wonderful presentation. Again, as a reminder, participants, if you have any questions, please put them in the chat. We have our presenters will be attending to all your questions in the chat, and we are almost done with the presentation. So we'll also have an opportunity to answer some of the questions live. But please allow me to welcome our co-moderator, Mr. Richard Chambade. Richard, I hope you're on. I would like to introduce you. So Mr. Richard Chambade is a colleague actually working with the Ministry of Water and Environment, but he's a professional. He is a professional in terrestrial and aquatic ecosystems management. He holds a Master of Science degree in Environmental Science and Technology with specialty in limnology and wetland ecosystems from UNESCO IHA Delft, the Netherlands. He also holds a diploma in limnology from the Institute of Limnology in Austria, and a Bachelor of Science degree in Zoology and Botany from Makerere University. Richard has over 20 years of experience in terrestrial and aquatic biodiversity research and assessment, as well as management of wetland resources, rivers, lakes, forests, and biodiversity therein. So Richard is routinely involved in policy planning and implementation, mentoring, and capacity building. Welcome, Richard.
Thank you, Mary.
The floor is yours to kindly invite our next speaker, to invite and introduce our speaker, who will be Mr. Basoma, and the rest of the speakers, and then you will also take us through the panel discussion. So over to you, Richard.
Thank you, Mary, for standing in. And colleagues, let me straight away invite Mr. Basoma, who is the doctoral researcher at the University of Natural Resources and Life Sciences Boku, that is in Vienna, Austria. Anthony is modeling biodiversity patterns in relation to network connectivity of European streams, rivers, and link deltas under Aquafina and Danube. Danube 4A for European Commission funded projects. Anthony developed species distribution risks for river network connectivity models to assess impacts of anthropogenic pressures on the distribution of species and fragmentation of river ecosystems. In Uganda, he's an ecological modeling specialist at NAFIRI, that is the National Fisheries Resources Research Institute. He holds a Master of Marine and Lacustrine Science and Management from Ghent University, Antwerp University, and Veitch University, Brussels in Belgium, and a Bachelor of Science degree in Fisheries and Aquaculture from Makerere University. I welcome Mr. Basoma to give a presentation on river network fragmentation, effects on spatial distribution and habitat connectivity of critical habitats for Labeo victorianus. Mr. Basoma, please. The space is yours.
Thank you, Richard. Yes, I'm going to present part of the work that is addressing the impact of mostly hydropower dams on the connectivity of our rivers in the Nile Basin. And for this one, I'll extract a section for longitudinal connectivity. So my topic today will be addressing the effects of hydropower dams on the network connectivity of equatorial lakes and Bahar Jabez sub-basins in the Nile River Basin. And yes, why river connectivity? Is because we are aware that as Africa, we need electricity because almost 43% of the population doesn't have access to electricity. But as we are doing this, we are fragmenting the rivers and streams considerably. And then this affects the connectivity of these rivers. And it's mostly hydropower dams, which are constructed on the river segments for hydropower generation, flood control, irrigation, and this consequently prevents the migration of species for food, reproduction, evading predators, also finding prey from the different ecosystems. And also this also reduces sediment transport and nutrient flows. And as we know that when nutrients are not flowing to the different areas of the river or the ecosystem, also productivity goes down. Why these two basins? As I've said before, that it's an extract of a wider study. We have conducted for these two basins and also for the Blue Nile Basin. But these two basins, one, they are hydropower dams hotspots. Like for example, currently we have 49 existing hydropower dams and 45 have been proposed, and then 8 under construction. So as we can see that this is the map of Africa, and then this is the Nile Basin. But if you look here, the dams are concentrated, both existing and the ones which are being proposed. And then this is the Nile, the Blue Nile Basin, and then this is yes, and this is the main Nile sub-basin within the Nile River Basin. So it is important to understand the connectivity of all basins, but specifically for these basins, they are hotspots. And then Also, it's a biodiversity hotspot, a critical habitat for migratory species, because River Kagera falls within this basin. River Kagera is around here, and this river is heavily used by a critical, now near threatened species, because it has been reassessed, Labeo victorianus, which uses the river for spawning. And then also IUCN has conducted a survey within the basins, and it was observed that the 204 freshwater species which are endemic to the Lake Victoria Basin, which falls under this wider basin, were 76% were at risk of extinction. So what is river connectivity, and what did I do? So I got the number of dams, or the dams that are on the network from the renewable power plant database. This is a database which was collected from after doing desktop work from a colleague from Germany. And then, because I'm also going to consider fish species, I got species occurrences from the Global Biodiversity Information Facility, which is an online database which has species occurrences. And then the river networks from hydrosheds, but we are going to change it to hydrograph 90M, which has a high resolution. But for this study, we're using hydrosheds. Hydrosheds is a database with different subcatchments and different basins for globally. And for this study, we only extracted for our area of interest. So river connectivity in brief, I can explain it. So we started in 1954 when there was no dam. Before 1954, there was no dam on this sub-basin. But then after 1954, they constructed Owen Falls Dam in Jinja. And then now the connectivity started changing. So as you can look at this theoretical connectivity diagram, we see that when you construct a dam here, then these areas are not connected to the one down. So if species are migrating from down going up, you can see that here they cannot cross depending on the passability of this dam. And the connectivity, you see that it has reduced from 100% to 55%, because now they cannot access this area. As you continue, you see that I've constructed another dam at point 2 and point 3, and then you see that the connectivity has reduced from 55 to 46%. Why not maybe from 55 to 0? It's because that you see that these dams are constructed on a low stream order network, which doesn't significantly affect the migration of species and different biota. So you can see that when dam 2, for example, is constructed, no species is being affected. Even when dam 3 is constructed, no species is being affected. So if you're prioritizing, then you need to remove dam 1, which will increase the connectivity by 50%, and then you almost have a better connected river. So in this study, what was so unique with it is that we considered all the stream networks, because in most cases, we remove small streams. But remember, these streams are used as a refuge for different species. And then if you remove the small streams, for example, this one, then it means you oversimplify the ecosystem, and then you don't provide a better solution to what is happening in real life. So in this study, we considered all stream orders, but remember that one is computationally heavy. I remember just running this sub-basin, it took like 5 hours. So if you know that you're running the Nile Basin, all of it can take like days. And then I used R with 2 packages, basically. but of course the other packages were used for visualization. But I used RiverCon, which has been developed by my colleague here in Austria, and then iGraph, which is an extensive package for handling networks or network diagrams. I used two connectivity indices. That is the dendritic connectivity index that takes consideration of the length of the streams that are, or the network that has been cut off. So for example, if you compute the dendritic connectivity index of 1, you consider the length of these streams which have been cut off, divided by the total length of the stream networks that you have in your subbasin. And then the stream continuity index, the stream order continuity index considers the size. It considers the stream order. So if you're computing now for dam 3, you have this is one stream order. So the average of it is 1 divided by now the average stream order of the whole network. And then for prioritizing, I used leave one out principle. Is that you leave one dam out, and then you compute the change in connectivity to see how the connectivity be affected if you leave out that dam in your computation. And then you can see that it is self-explanatory that if I leave out dam 1, the connectivity will be almost 96 or 97%. So that is the principle behind this study. And the results, I computed the change in connectivity from 50%. So on x-axis, on y-axis is the change in connectivity over time. Then I set 50% as a cutoff point. So if the connectivity goes below 50%, then it means we have disconnected the network by 50. And then I computed the difference from 50% mark and see whether it was significantly different from the connectivity that we had. So we can see that in 1954, it was 55.05, of course, from 100. But when we constructed Owen Falls Dam, connectivity reduced to 55.05. And then because there was no dam until 2004, when the Killer Dam was constructed, it reduced to, this was until 99. Of course, there were few dams which were constructed, but they were not on higher stream orders like Mobuku, but these were small dams. I think there were some also dams in Rwanda which were constructed, but these were constructed on small stream orders. We can see that the connectivity went below 50% mark. The 50% is now the 0 here in 2008, and then it went further to below again 2017. This is a range of 9 years, and then it will go down here to around it's reducing by almost 30% from 50. So that's like 20, then like up to here like 18.65 in the future, that is 2035. So if you consider the dams that are being proposed on the network, then the connectivity will be 18.65% from what was in 1954. So you see that we are destroying the streams or the rivers because we need electricity, but we have to do it reasonably considering the ecosystem and also in general. Because if fish is not migrating, if it's not producing, then at the end of the day, we shall lose all. We shall have power, but with no food, and people will die because there will be no food. And then I was testing if when we add on a dam, if we increase the number of dam, how will the connectivity changes? What is the correlation? And we can see that if you consider the dendritic connectivity index and the stream order connectivity index, we see that it was significantly different, and the R value is quite high, that as more dams are added on, the connectivity also reduces. But there is a time when the networks are sparsaturated with dams, when you don't see that that the connector is reducing, when like nothing can change because almost everything has been added on. And we are seeing it here in Europe, because for my PhD, I'm working on riparian streams, where you see that the connectivity has stopped reducing because everything is sparsaturated, and then what you need to do is to remove some of the dams. So as I've said that it was computationally heavy, and we considered all stream orders, we see that you almost don't see any white spaces, but these are streams with from 1 to 7, because for the Nile River Basin, this particular basin had up to 7 stream orders. So the stream order number, the more it increases, the more like the stream size increases as the stream order increases. So if you have a stream order of 7, then it means also the stream size is quite large. So we see that the connectivity now here in 1954, we see that up was a bit okay, but down was reducing, because if you look at the scale, and it almost remained constant up to 2017, because as these dams were added, they were being added on small stream orders, and it was not significant affecting the connectivity of the sub-basin. But when you go to 2026, so from 2017 to 2026, you see that in the different sections of the sub-basins, we see that the connectivity is significantly reducing. And in 2035, I can't see my cursor. And in 2035, we see that it is now a clear pattern that this section where River Kagera is, and this is, I think, River Nzoia, I think, is considerably fragmented because of the proposed dams. And remember, as I've said before, like this area here is important for label, which is, I think, a critical endangered species, but it has been reevaluated to near threatened. And then in the middle section here is where you find Karuma, you find, I think Orianga is also proposed here. There are so many dams which are being proposed here. So we can see this is Lake Victoria, and it is inter, because there are streams that are going through. When you look at the hydro rivers shapefile, there are streams which are going through, but we see that it is not affected so much. But here it is affected, and here on this Lake Albert is around here, and there are dams which are being proposed and which are also being constructed in this section. So we see that the connectivity was high in the upper section of the basin from 1954, when the first dam was constructed, and until 2017. And then high reduction in the network was observed in the middle section, and also in the southwestern and eastern side of the basins. So these basins were connected. So that's why you're seeing that I've not separated the analysis, because these basins were connected. They have one outlet. So when you're computing the connectivity index, you need to find the outlet of the basin where water gets out of the basin. Then you can compute for the connectivity of that area that's being served by that one outlet. So for prioritization, we see that Karuma in our prioritization, we didn't go below we didn't follow the historical trends, because you can't prioritize when we have already passed it. But for now, if you are to consider prioritizing, then Karuma needs to be managed, need to be looked at critically, because it reduced the connectivity by 34%. So when you look at what I presented before, or 50%, if you put a dam on a higher stream order, then you know it will affect the connectivity. So you see that Karuma had a high contribution on the fragmentation, using both DCI, the dendritic connectivity index, and then using this is stream continuity index, stream order continuity index, and then this is the dendritic connectivity index, as you can see here on the legend. And then if you now extrapolate to 2035, when more dams are now being proposed on the network, we see that Naviole Dam, I think Naviole Falls Dam is around here. So it's being proposed, and we see that it will reduce the connectivity significantly by 6.24. Someone will ask why is it that again it is on the periphery, but it is significantly affecting. First of all, you see that it is 6.24, it is low, but again, whenever a dam is constructed, it changes the configuration of the network. The centrality shifts. What was central before the dam was constructed now changes, because it creates two different separate ecosystems, and now each ecosystem has a central point. Yes. And then, so my conclusions are, so the dams in the mid and lower sections affected the river network connectivity, and then Karuma Dam needs to be effectively managed. First, like constructing the fish path, if it is there. So if it is not there, then we need, if it is there, we need to maintain it. If it's not there, then we need to construct it. Then also another thing is to, for Naviole Dam, it needs to be repositioned in case it is considered, or we just abandon the proposal because it will significantly affect the connectivity of the basin, of the sub-basin. Another thing has been on dam removal, but that one has not yet gotten interest from Africa, because first of all, our dams are still new, but then also we need electricity, so there are some bit of competing interests. That's why I have not indicated dam removal. But like here in Europe, now dam removal is being considered, because as I've already said, most of the river networks have reached saturation. Now that even species cannot migrate, and now even when you cannot add on, but instead remove for it to ensure that there is some bit of connectivity. And then the recommendation I have, I've shown that we are blind. We don't see what is we don't understand the full extent and severity of the river network connectivity, because even the database that was used, it was a desk study that involved checking online on the number of dams where they are. Sometimes I checked and the dams were not on, some were not even on the network. So there was some bit of cleaning, but for now, that is the information that we have on the dams. So I was strongly recommending that we need to do an enumeration of the barriers, whether small, large, on the river network. Because if we don't understand, this, then we might be only considering the large dams, when even the small dams that are on small stream orders are affecting the connectivity and also the species migration. So those are some of the references.
Mr. Anthony, thank you so much.
Thank you.
Yes, in terms of time, I think participants, wherever you are, just clap for Mr. Anthony for the good presentation he has made. Of course, there are key issues he raises, and it's a balance of development and the life of rivers, connectivity, ecological issues that he's raising, especially with regard to migration of fish and other organisms that may be using these rivers. So we need to have balance on how we develop our dams, especially with regard to the life within these rivers. Thank you so much, Mr. Anthony.
Okay.
Yeah. And as the practice has been, let's go to the chat and have our questions in there. I remind the participants that we have 3 more presentations, and we shall have a session on question and answers, or the presenters will be able to get some time to respond to these questions. Let me introduce the next presenter. The next presenter is Dr. Albert Kasey. She is a postdoctoral fellow at Germany's Leipzig Institute of Freshwater Ecology and Inland Fisheries. She holds a bachelor's degree in fisheries, wetlands, and wildlife management from...
Excuse me, moderator.
Yes, please.
Doctor is not on the call. Maybe you move to the next.
We move to the next. Thank you. Thank you, sir. As we wait for Dr. Kasey, I would like to invite the next presenter. This is Mr. Irga Kebede Wondin, who is a PhD holder, a PhD candidate at, he's a PhD candidate in Aquatic and Wetland Ecosystem Management, Faculty of Agriculture and Environmental Sciences, Bahilda University in Bahilda, Ethiopia. He's a graduate of the short course certificate in strategic environment assessment and the environmental impact assessment. He applies spatial decision support tools from the University of Twente, the Netherlands. He also holds a master's degree in environmental science from Addis Ababa University. He graduated with a bachelor's degree in geography with a minor in geography from Addis Ababa University. I would like to invite Mr. Irga Kebede to give us a presentation on sediment characteristics or water chemistry. It's a question. Is it sediment characteristics or water chemistry? On partitioning the role of sediment characteristics and water chemistry as drivers of macroinvertebrate assemblages in lacustrine fringe wetlands of Lake Tana. Mr. Kebede, please, you're welcome. Hello, Mr. Kebede.
Hello, moderator.
Yes, please.
Hello, moderator.
Yes, please. Yes, Dr. Jin.
Yeah, we can go to Zo who is online. If the 2 remaining are not joining, after Zo we can continue with a Q&A session.
Okay. Dear colleagues, as we wait for connectivity from those presenters, I think let's invite Dr. Zo Rosenblatt from Oregon State University, USA. She's a doctoral candidate in geography at Oregon State University. Her research explores the intersection of international water governance and transboundary wetlands, investigating the role of law and institutions in shared water areas. She employs geospatial and qualitative analysis to understand global distribution of transboundary wetlands and how transboundary wetland governance is implemented on ground. Zoe is a graduate of water cooperation and diplomacy with a master's from Oregon State University, IHE Delft, and the United Nations mandated University for Peace. Let me invite Dr. Zoe to make a presentation.
Okay, thank you.
Please go on.
Okay, great. Thank you for the introduction and for inviting me to present. It's a pleasure to be here today to learn about and celebrate the Nile. My research explores wetland governance on a global scale, and today I'll briefly share some observations that might be useful for the Nile. And so for my presentation today, I'll use 3 examples to highlight how human activities affect wetland health and biodiversity, and how river basin organizations support protection of critical wetlands. And these 3 case studies will be the Okavango Delta, the Hamun wetlands, and the Colorado River Delta. Then I'll share briefly some global findings and finally wrap it up. So Dr. Zeleke already mentioned many of the benefits of wetlands earlier at the beginning of this presentation, but just to again reiterate that not only are wetlands one of the most productive habitats on Earth, but they also provide many other benefits. They're important for cultural reasons. They provide food and fuel and habitat space. They provide floodwater protection, carbon sequestration, and many other benefits that are important for mitigating climate change. And wetlands are found all across the globe. So this map from the USDA shows where wetlands are, and they're located on every continent except Antarctica. So the different colors on the map show different types of wetlands. Despite wetlands being everywhere and being very important, somewhere between 20 to 90% of wetlands globally have been lost, depending on which research studies you prefer to follow. And this loss has come from many anthropogenic changes, such as conversion into other land use, such as agriculture or housing developments, and also from climate change and other factors. So now I'll dive into the 3 case studies. The Okavango Delta in Southern Africa, the Hamun wetlands in the Middle East, and the Colorado River Delta in North America. And these 3 photos highlight some of the differences between the cases. The Okavango Delta is home to many charismatic megafauna, like these elephants, and is a popular tourist destination. The Hamun wetlands, once home to many, once a significant stopover for 400,000 migratory species of birds, is turning to an area stricken with sandstorms here. It's very dry. And the Colorado River Delta, once dry, is now seeing water again from restoration efforts. So the Okavango Delta is fed by the Okavango River, which originates in Angola, flows through this little strip of Namibia, and then forms the delta in Botswana. Although the delta is wholly in Botswana, it relies on the water flowing from Angola and Namibia, and therefore is considered transboundary. And some important considerations for the Okavango Delta are that it is a really important place for tourism. So when we think about it relying on the water from the upstream countries. We might wonder why. Why does it still get that water? And one reason might be pressure from the international community. So tourism to the Okavango Delta is the second largest source of GDP for Botswana. And Angola, Namibia, and Botswana work together through OCACOM, the river basin organization on the Okavango River, to protect the delta and also allocate the water resources of the river, among other tasks. The Hamun wetlands were once home to rich agriculture, and yes, the Hamun wetlands are fed by the Helmand River, which originates here in Afghanistan and flows down into Iran. And there are a series of wetlands here, some that cross between the two countries and some that are located either in Iran or Afghanistan, all fed by the river. Some of these wetlands are becoming very dry due to decreased flow to the wetlands. And the anthropogenic activities are largely agriculture. There is not cooperation between the countries formally on protection of the wetlands. However, Iran, with the support of UNDP, has started some efforts to restore the wetlands. And finally, we have the Colorado River Delta. The Colorado River originates in Colorado here in the United States, flows down through 7 states, and ends in Mexico at the Delta area. On this map here, you can see a number of dams. And so these dams are mostly for irrigation for agriculture. And over time, actually, the dams began to store so much water that the river actually didn't even reach the delta anymore. And so it no longer flowed into its endpoint. So here you can see a picture of the dried up delta. And in 2013, the International Boundary Waters Commission, which is the river basin organization tasked with managing the waters that are shared between the US and Mexico, began an effort to restore the delta. So they, the countries agreed to release certain amounts of water in the dry season so that the river could flow through the delta once again. They then renewed those efforts in 2017, and the delta continues to be undergoing restoration. So we have these 3 different examples of how human activities have affected wetlands. In some cases, very positively, protecting the areas for the benefits that we receive from them. In other cases, you know, the agricultural expansion has really made a negative impact on the wetland. And we've seen how in the first case and the last case, the River Basin Organization, OCACOM, and the IBWC have played a role in that wetland protection. I'd now like to just very briefly zoom out to look globally at some research that my team has done. So you might be familiar with this map here of the international river basins of the world. We know that there are 313 rivers that flow across country borders. Here you can see the Nile Basin. Then this map is from IGRAC and UNESCO of the transboundary aquifers, of which there are about 500. And then research from my master's found about 300 Ramsar sites that cross country borders. So if you're interested in that, you're welcome to see that paper. And just to conclude, despite wetlands being an area where countries cooperate and work together often to restore them, they're not sufficiently accounted for in international freshwater agreements. So some preliminary research of mine has found that only about 10% of the more than 800 international freshwater treaties mention wetlands at all. And often the wetlands are mentioned in a way where the countries agree to drain them. So protection of wetlands is not often done through treaties. Despite this, though, freshwater treaties and river basin organizations are existing governance mechanisms that could better protect wetlands, like the Nile Basin Initiative is doing in the Nile Basin, mapping them out and developing the wetland management strategy. And like the International Boundary Waters Commission is doing with restoring the Colorado River Delta. And then wetlands that are drying up, like the Hamun wetlands and like the Mesopotamian marshlands that you may have seen in the news recently, serve as urgent wake-up calls for us to protect the world's wetlands and other fragile ecosystems. So we hope that the Nile Basin and also that my country, the US, and others can protect their wetlands before it's too late. So thank you, that's my brief talk, and there's certainly more to discuss about transboundary wetlands governance. So if you'd like to chat with me, feel free to reach out on email or find me on LinkedIn. Thank you.
Thanks, Dr. Zo, for the presentation. And I think now, I don't know, Dr. Jean, do you have any other presenter now online?
Hello, moderator.
Yes, please. Do you have any presenter now online?
So far, I'm not seeing the other two presenters, so we can continue with just the Q&A session.
Q&A, yes.
And you will continue also with the panel discussion.
Yes, please. Now, what I'm trying to do, our participants, is that I think we have different versions of Zoom. I'm trying to have the questions posted in the chat box. You can check the chat box right now. And I encourage your presenters to visit the chat box so you can answer the questions that have come in from participants as we go into the open Q&A. Okay, for the presenters, please visit the chat box and try to answer all the questions that are coming up. So we've missed 2 presentations. Out of the 7, we've had 5 presentations. And I would like to invite participants to have their questions directed to the presenters. Because we've gained some time, we can have 2 or 3, 1 or 2 questions to any of the presenters that for the presentations that have been made. I open the floor for whoever wants to ask any of the presenters who have made presentations since morning. Thank you.
Somebody, there is a hand up of Muhammad Yassin.
Okay.
Thank you. Hello, you hear me?
Hello. Yes, we can hear you.
Yeah, thank you very much. Go directly to Muhammad Yassin from universities in Europe, and was a former first undersecretary of federal governance in Sudan during the transitional government. I have a question of two folds. When this goes to maybe to Dr. Anthony and maybe Zoe. Dr. Anthony, you mentioned that there are currently around 45 dams, 49 existing dams, 45 proposed, and 8 under construction. Assuming that in the future, bulk of these proposed dams will be erected or constructed, that may lead to disconnectivity, if you can confirm that. And in such a case, this is going to maybe necessitate or impose a new paradigm for the management of the basin as a whole. Do you expect a scenario like the scenario of Colorado River with Mexico, what has been mentioned by Zoe, by the presenter from the University of Oregon, and maybe if Zoe can also give us a possible scenario of the same scenario, which is presented in between US and Mexico in this case. Another question goes also to the presenter of the first presenter on the fish. In introduction of new species, maybe non-indigenous fishes, like what happened in some lakes in the Nile Basin, may compromise the balance, the ecological balance of that lakes. Do you notice that maybe in this case in Victoria Lake or other lakes, and especially this also induced to overfishing, because the fishermen, they target certain species and they because they are marketable. Thank you.
Thank you, Mohammed, for the questions. And I think should we just give chance to the presenter to make response? So do we have any other person making comment, question, or clarification being sought from the presenters?
Hello, moderator.
Yes, please.
Yeah, I was checking also in the Q&A box.
Yes, I've posted the number of questions there that have come from.
Yes, very many questions.
Yes.
Just targeting Prof. Gordon.
Yes.
And Dr. Rebecca, I think they can check them or just give a kind of a brief on many questions asked to them. Thank you.
I'll invite any presenter, please, to make clarification or give answers to the questions. First to the one made by Mohammed, and maybe the others that are that have been brought to the chat box. Yes, please.
I welcome the questions. They are quite interesting. And that is the way to go, because we need to address this issue before it goes out of hand. I'll first address the one that has been raised by Mohammed, I think. Yes, these dams are already known, as I've already said before, that there is a database that has these dams, and I've presented the reference to it, that the database that I used to construct the network connectivity. So it is true, there should be a paradigm shift in the way we handle the connectivity issue, because in most cases when a dam is being constructed, we consider the section where it's going to be constructed. But these dams don't only affect the section where it is being constructed, it affects the entire basin. And addressing the connectivity at the basin-wide level, it would be the way to go, because when you're constructing a dam in Kagera, you're forgetting that there are species that move from Kagera up, maybe from Lake Victoria to Kagera, from Kagera to Lake Victoria. So for you, when you're doing analysis, you will check the species composition near where the dam is going to be constructed, and you will forget that these species are migrating in different ways. So yes, there should be a paradigm shift. Another thing is in my recommendation, understanding these barriers, where they are, and then we understand the severity. Then on the fish ladders, yes, fish ladders are promoted, and or fish passes are promoted. And also in my conclusion, I recommended that if we have passes, then we need to maintain them. But we should not also forget that these fish passes only are for specific species. There are some species which are passive. There are some species which are sedentary. They cannot go through the fish pass. But so for example, if you are constructing on Kagera, we shall consider labeo because it's the only threatened species that is known on the river. But we don't consider what it eats. There are some macroinvertebrates. There are some species which feed on macroinvertebrates, and these macroinvertebrates, these macroinvertebrates, they also need to migrate because the different species migrate. So these fish passes, as you hear, it is a fish pass. It is not controlling nutrients, not controlling sediments. And as we all are aware that in Egypt, the sediment that goes to Egypt doesn't come from Egypt. This sediment comes from
the highlands.
Comes from these areas to Egypt. So when you're constructing a dam, you need to consider, even maybe should I call it a sediment pass, for you to get what I'm saying for the connectivity. So for connectivity, it's not only about the fish, but the fish and this ecosystem. But since we eat fish, that's the only thing that we consider. Also, nutrients.
Thank you so much, Mr. Basoma. And I think this is where we have to, we should not be looking at structures only, but the sediment is very important, because not only is it habitat, but also provides food for the different organisms, including the fish. But yes. I think making it clear that his focus was so much on labeo, whatever labeo is in common English, I don't know, but I think you are a bit specific on the type of species that you are looking at in terms of the connectivity of your presentation. I would like also to chip in and ask Dr. Zo and Sazele, that with the experience from Okavango, Colorado, and the other basins, how do we bring this experience and information in supporting the CFA over the use of the Nile resources? And I don't know whether this is clear, Zo and Select. How do we bring this vast experience from the 3 river basins to the CFA, the Cooperative Framework Agreement that is proposed for the Nile? Thank you. With regard to the wetlands, the transboundary wetlands, and even the other resources along the Nile. Thank you.
That's a good question. Thank you. I think, for one, I think it's interesting to see the example of the Colorado Delta using the River Basin Organization to bring the countries together to make the wetland restoration happen. And so that institution also was able to mobilize the funding and resources, right, to serve as the overall institution overseeing the restoration and to make sure that the restoration happened over the years. So they we're able to oversee the legal side of making it happen. And in terms of the Okavango, I think it's interesting to see the focus on tourism there, and how since Botswana especially sees the value of the Delta to their GDP and their income, it might be interesting for other cases to see how the wetlands are valued, and to look at benefit sharing as well. So if one country really values the wetland and needs the water from a different country, then looking at sharing benefits so that the upstream or downstream country, whatever case it might be, can also receive benefits as well from sharing the water to preserve the wetland.
Okay. Thank you, Zoe. To Professor O'Brien, there's a question for you. Is the framework you presented being implemented in the Nile Basin? If so, who are the players? Is the framework being implemented in other river basins apart from the Nile? What are the challenges for its implementation?
Hello, moderator.
Yes, please.
Yeah, I'm not seeing Dr. Professor Gordon online.
Yeah.
But I think I'm with Tom Wako. He can comment on this.
Okay, please. Thank you. Tom Wako.
Okay. Thank you, Richard, for that question. Regarding the implementation of the e-flows framework, the implementation of most of these frameworks are done by the countries. What we do as NBI, as a center of knowledge, we prepare the frameworks that can guide, sustainable practices in the e-flows area, and then we promote them among the countries. The implementation of these tools are usually at the country level. So after we have developed the regional tools, we only do the promotion and the monitoring and evaluation to see how they are being implemented. So in terms of implementation, we just promote and build capacity for them to be effectively implemented in the countries, and also cause a platform to be effective and works around this particular area. So I could say we have provided enabling environment for these frameworks to take root at the country level.
Okay, thank you. This is bringing...
All right, over to you, moderator.
Yeah, thank you. Thank you, Tom. This is bringing the research and science information to policy and practice. So the different countries, as clearly stated, are supposed to take on the implementation of these. I hope this is very clear to Dr. Oliver Nasirwa, who asked this question. But also, I don't know whether, Tom, you can attempt this one, that e-flow has remained at studies and frameworks, even at the Nile Basin, which you characterize as progressive with regards to the matters of e-flow. Have we only remained theoretical? How can we practically implement the e-flows in the water planning and allocation? I don't know.
Okay, Richard, we could also attempt that one.
Yeah.
What we did, like you saw from Professor O'Brien's presentation, it was really the cost analysis.
Yes.
There was an idea of going in a more detailed analysis to have that basin-wide approach on the e-flows, which we have not yet embarked on due to funding constraints. But in terms of monitoring, we have what we call the state of basin reporting, which has got a number of indicators which we monitor. Some of them are related to the e-flows. So we monitor that every 5 years. We follow those indicators and see how they are evolving after every 5 years. But like I said, our role really is to provide an enabling environment for these good practices to take root in the countries. And we leave the countries to do the implementation of the good practices that are identified at the regional level.
Our participants, thank you so much, Tom, for the response. Our participants, any burning question before we go into the next session? We are, of course, it's unfortunate we missed 2 presenters, but we also made time to have more detailed discussions about what has been presented to us. Of course, we missed out on 2 presentations that concern benthic macroinvertebrates. And then the other one was on plant communities of Lake Tana.
Hello, moderator.
Yes, please.
I'm seeing Miss Mary hands over. So
yes,
hand is up. So if she has a question,
please, Mary.
Yes, thank you very much. I think Professor had posted in the chat that he was leaving the call, but he left there his contacts for anyone who would like to ask a bit of more detailed questions, which probably cannot be answered by the presenters here or the NBI colleagues. But my question is to Chala on the wetlands atlas. Could you just make a note? Is this wetland ready to be shared with the public? Is it available on the NBI website? What is the status here? Thank you very much.
Yes. Mr. Chala, are you online, please?
Okay. Thank you for the question, Ms. Mary. The wetland is it is ready, but we have some issues to resolve. So it will be shared very soon on the website, as well as will be printed, and the hard copy will be also available in different libraries of the Nile Basin countries.
Okay, thank you. On the issue of connectivity, Mr. Basoma withheld, or I think was cautious, on recommending the removal of dams. And I see in the chat somebody is trying to ask, what more improvements can we make as ecologists, as environmentalists who mind environmental flows, not only of energy, but also food and all that, to ensure that we provide better or improved solutions to connectivity, at the same time having the dams in place. And of course, I also want to know at what time will Africa be ready to remove the dams, as you hinted on in your presentation, that some of the European countries are doing away with dams. It's a bit controversial, but try to throw more light on how we can have better or improved connectivity of rivers, at the same time have the dams that provide us with the much needed energy. Apart from the fish steps and fish corridors and all that, can we have better mechanisms to ensure that connectivity is in place?
Yes, thank you, Richard. And you're spot on about the dam removal, because I said it's not, I don't think we are ready as Africa now to remove dams, because we have even a deficit of 43% of the population that don't have access to electricity. But my idea would be to ensure that we prioritize sections where we are constructing dams, because in most cases, these dams are constructed, but in areas that you see that when you construct it, it will affect the connectivity severely. For example, some wanted to construct a dam at Makshon, but why do you construct in an area that like a hotspot for biodiversity? Because then you will come up with species are using that area so much. So it's better to prioritize areas that are a bit that are not highly used by the species, that are not highly diverse, and then we we construct dams from there. So, but also we need to do it at a basin-wide level. We don't need to. We should desist. We should stop assessing areas specific to where the dams are going to be constructed. But we need to put the basin in perspective in terms of connectivity. Thank you, Richard.
Thank you. I think we've lost Richard, but thank you, Anton, for responding to that question. Dr. Nabi, there were also some questions to you in the chat. Did you get those by any chance? Would you like to comment on that?
Thank you so much, Miss Mary. Yes, on the Q&A, I've tried to answer most of the questions, if not all. Then in the chat, there was a question from Mr. Okello William about the Kamuli site. Yes, the Kamuli site is not at the mouth of River Nile. It's actually a small island, and if we can protect it so that people don't go there to do agricultural activities, it can really help on boosting Nile tilapia growth or production, because it was really a good area from the samples that we picked from that site. So Kamuli site is a very good site that needs to be gazetted. Then Miss Mary also asked about the military. The military, it's helping, but not on some of these technical issues. Yeah, for them, they know, like, okay, if they find somebody with an illegal gear, yes, they can impound to some extent. But going into knowing they should not be set here, they should be set here, we need to bring them on board, because they don't know some of those technical issues to that level. Then you talked about that, the ATAS project. Yes, it did some work with Nafiri, but some of this work, especially for Lake Choga, it was inaccessible. It's not either published or not yet. I don't know in which state, like the one for Victoria and Albert, as we all remember. The sites on Albert really helped us when the Ministry of Energy came in to say the oil wells and where to put them, because the sites for fish breeding sites on Lake Albert were already there. It was really a good guide. So for Lake Choga, we needed to do a review, and I thank the GIZ people. I think late last year and early this year, they also went ahead to do more work on these fish breeding sites, including even the Kwania Arm, and we were in touch. So we ATAS did some work, but we need to consolidate all this in order to protect Lake Choga. Then somebody talked about, I think it was Leonard, lacustrine areas. Even fish breeding habitats or sites are part of these lacustrine areas. For them, it's a bigger thing, and he was wondering how the society can come in to help. We really need co-management in conserving or keeping these sites, because for us, sometimes we are not there. But if we bring on board the local people, even creating alternatives, we can really help protect. For me, I talked about fish breeding areas, but if you talk to somebody from maybe another ministry, will come in to bring in other natural resources, the ecotourism sites. All these sites need to be protected, but for today, we were more into the fisheries resource.
Okay.
Thank you so much.
Okay. Thank you very much, Dr. Nambi. And I know, yeah, we have Dr. Okello here from Nafiri. Dr. Okello, I'm sorry, but I'm going to put you on the spot to come in here. I know Nafiri has been has been championing or leading several research activities, especially around fish breeding sites, characterization on major Uganda water bodies. Most of them are in the Nile Basin. Can you make some comments on this? Where do we stand? Where can stakeholders find this information or data or publications, if at all any have been published? If you could unmute yourself and say something on this regard, as I check if my co-moderator is on. Otherwise, I would like to suggest that we move quickly after you to our panel discussion.
Before he comes in,
Hello?
I would like to just inform participants that I think we've merged the two. We are already into that kind of the panel discussion.
Okay.
Yeah. But let's make it snappy. For whoever is making a comment or question, make it very fast so that respondents, I mean the presenters, are able to have more time to respond to the questions, please.
Sorry, Dr. Okello have
Dr. Okello?
The meeting.
Has exited the meeting? Okay.
From the chat, that's what I'm reading. Okay.
Now, as maybe somebody can signal him to come back, because Mary seems to be on his case. we shall get him back. But as we discussed, I think we realized two or three things. One is that with regard to water, water is either too much, too little, or too dirty. That's where our problems are. When it is too much, we get floods. When it's too little, we are in drought or scarcity. When it is too dirty, we are talking about pollution. So we should be seeking for solutions in those three areas. When it comes to ecosystems, I think we are looking at the threats to ecosystems as encroachment and degradation, which degradation takes very many different forms, including the pollution that I've mentioned about. This encroachment and degradation, of course, lowers the quality and functioning of the ecosystems. We see issues of sustainable development coming in here. How do we balance the developments that we really need so much, but also maintain the functions of the ecosystems that we rely on so much to survive on this earth? I still have something that is coming in that seems not to be going away to Mr. Basoma, but to any other fish expert listening in, the issue of ladders or passes of fish when dams are constructed. They seem not to be effective. I challenge ecologists, I challenge environmentalists to join up with the engineers with coming up good and effective means of maintaining connectivity of upstream and downstream areas of rivers when dams are being constructed. The current ones don't seem to be effective. How do we go about this? This may not be specific to Mr. Anthony Basoma, but to whoever can make suggestions here. Thank you. Otherwise, I encourage participants online to make more questions, and if not, then each of the presenters can be given 2 minutes to make more clarification on the presentation then. Thank you.
Yes, Isaac's hand is up. Isaac, if you could quickly unmute yourself. Isaac Oluwa Ojo.
Usually should be. So, in the meantime, I think any presenter who has anything to make clarification on, please, just check your chat box and see whether there's anything that we may want to make response on. And I encourage you presenters to ensure that before maybe we close the session, you've answered these questions either online or here in audio. Thank you.
Yeah.
Mr. Chala, please go ahead.
Yes.
Please go ahead.
Yeah, there is one question for me from Muhammad Saleh. Can you share the Atlas PDF? Yeah, we are finalizing the Atlas. When it's ready, yeah, we can share with you, and I will keep your email. Thank you.
Okay. Okay.
Maybe if I can also highlight on what Mohammed said on if we consider the 45 dams, are we facing having the same issues that are in Mexico or USA? Yes, but since they are proposed, we need to wake up now. Since we can do the connectivity analysis, we have the capacity to do a connectivity analysis, then we need to do that and ensure that when a dam is going to be constructed, it is not affecting the connectivity, because it is not true that whenever you construct, it affects the connectivity significantly. It depends on the area where you're going to construct it. So, and also we need to understand the effectiveness of the measures that are going to be implemented. So if you're going to construct a fish path that is only considering one species, that one will not be effective for the ecosystem as a whole. We need passes that considering a lot of aspects, sediments flowing, nutrients flowing, the flow regimes, and in that we shall have electricity, but with a good ecosystem. So we shouldn't be looking at only electricity, because we shall have electricity, but when people are not getting food, are not getting water, which we don't want. So as ecosystem scientists, as people who are working on these rivers, we need to come together and address these problems as a whole, not blaming one another, but we need to address these problems as a whole.
Okay, thank you, Anthony. And online, I think this is Engineer Ronald Mugambe. Says the only structural solution for addressing problems of drought, flooding, and too much or too low water is having multi-purpose dam construction. You construct multi-purpose dams. I think this is something we can continue doing, and I mean adopting. Can adopt this, but at the same time, we think on how many purposes or how many uses these dams can be able to handle, depending on terrain, depending on location, depending on all that. So for any more of this, I think Engineer Mugambe is available for discussion. Presenters, any other presenter online here? Dr. Nambi, Nalsek, I think this is Mr. Chala. Do we have any comments that you would like to make with regard to your presentations?
I would like to thank the audience, the organizers, and everyone, and those who have sent in the questions. Together, we can work to save our natural resources in the basin, including fish. I can see discussion about label. Yeah, dams are really another hindrance to their biodiversity and also reproduction. But together we can, through collaborations and guidances, work out to save our natural resources, because at the end of it all, we all need food and also better livelihoods. Thank you so much.
Thank you so much, Dr. Nambi. And I would like to encourage participants to still come in. In the meantime, I would like to also mention that while we have to develop, our development should be able to enhance the ecosystems that we rely on. The enhancement of these ecosystems is very important, especially if much of our activities as humans are actually impacting on them. So we should be at one point able to enhance the performance and functioning of these ecosystems. How do we enhance? Sometimes it may be possible to have the structural measures in enhancing the performance and function of these ecosystems. Other times it may be necessary to restore. When it comes to wetlands, you've seen the presentations being made that we've lost almost 87% of our wetlands globally. And in the Nile, you saw that wetlands make up only 1.1% of the entire basin. In Uganda, we talk of a certain percentage, but somewhere, somehow, those wetlands that can be redeemed, that can be restored, I think we need to be going that direction of restoring those degraded ecosystems. And I think most governments are moving towards this. And in light of the climate change mitigation and adaptation measures agreed on globally, we need to conserve some of these ecosystems as we now adopt the carbon neutrality aspects of climate change. I think we need to look at them that well-conserved ecosystems can earn us some revenue in these markets that have been put up under the climate change adaptation and mitigation efforts. But I also see that it will be very important for countries to invest in data collection. It may not be easy to have it. We already have the tools. From the first session, we are saying the tools are available, but somewhere, somehow, we need to collect data that is reliable, that can be fed into these tools, so that we are able to model and maybe predict what is likely to be in our basins. So we need to invest and collect reliable data that will be used in these tools for the management of the Nile resources. I'm not sure, do we have any other issues, maybe comments that come in?
Eric has raised how our researchers are informing concerned institutions to consider issues and what can be done on the level of the Nile Basin. Yes, I think that's what we are doing today, because this one was organized by the Nile Basin. And as I've raised it, we need to consider connectivity as a major problem. And on the issue of data collection, yes, Richard, you're right. My recommendation was to make sure that we even know these barriers, the small ones and the large ones, because even small barriers are constructed on small streams. I think someone said that there are these fishers who divert water, and I remember for Labeo, those days when it was not dams, they were constructing barriers to prevent the migratory, the spawning fish that was coming from the river, and they trap it from there. And it decimated these populations those days. But now we have dams. So we need also to know those small barriers. And I think the Nile Basin initiative or the institution should look into that. I have the proposal for it in case it needs my expertise in terms of getting the data, and we model what will happen at basin wide level. For the Blue Nile, we have the results, and also for this small basin, we have the results, and we need to do it at a basin-wide level with all the barriers in place, and then we more than see the connectivity on the different species.
Okay, thank you, Anthony. We only have about 5 minutes to close this session. I'd like to thank all the presenters and participants of this session. Thank you so much. But take-home messages maybe may include basically having improvements in the fish bypasses or fish ladders. I think we need to work more towards that to see that maybe the issue of doing away with dams may not be tenable at the moment. Let's see how we improve our recommendations to engineers on how we can maintain connectivity, minimize the disconnection between the up and downstream parts of rivers. I think we also need to enhance ecosystem function, as I said, how there are many options, and conservation, you can do restoration, you can go into total preservation as in gazettement, and we make some of the remaining ecosystems that are important to us as conserved. And as I've already linked these conserved areas to the carbon markets, I think it's an area we can venture into as Nile Basin countries. Countries are encouraged, of course, to invest in the implementation of the frameworks that have been developed by the Nile Basin, the NBI, as indicated by Mr. Wako, that the frameworks are available. Countries should be able to come in, use and implement some of the frameworks for the management of Nile resources. I don't have much to say. I would like to thank all the presenters, the participants, for the information that has been shared. This is all in the name of protecting the Nile resources and using them sustainably. I thank the Nile Secretaries for hosting us and giving us the opportunity to communicate the scientific and research knowledge that has been generated in the last 1 year. And I think we shall be back at this forum. Maybe the next forum we shall be presenting more information, either in line with what we've discussed here, or even better in other areas that may be of challenge as the situation may determine. Thank you so much. Thank you, Nile Secretariat. Thank you, participants and presenters. Have a good day. Back to you, Secretariat.
Thank you, Richard, for good moderation. Thank you, presenters and the participants. I hand over to Tom Wako to give the closing remark. Thank you. Thank you. Thank you.
Okay, thank you, Dr. Ja and the team for organizing the webinar. Thank you, Richard and Mary, for moderating the session. It was indeed a very productive session. We've heard a lot from the e-flow on the wetlands and on the fisheries. The Nile Basin Initiative takes the environmental goal as a very important goal, which looks at nature, and through it, there is a lot of interest to learn and provide information and knowledge that can sustain the basin. So I want to thank you, and also encourage you to join the next webinar, which will take place on Tuesday. As you know, tomorrow, Monday is a public holiday in Uganda, Independence Day. So on Tuesday, we'll have EN3, another interesting webinar. Don't miss out. Please join and continue following up the webinars. And of course, we'll have summaries of these presented at the physical NBDF 7, which will be happening on 16th, 17th of this month. So thank you very much, and I wish you all the best. Thank you. Bye-bye.
Bye-bye.
That's it.
From Command Center, thanks to all of you. Bye.
Thanks, Dr. Zah.
Thank you, everyone.
Thank you.
Thank you. Thank you.
Thank you all. Bye-bye.